Welcome to Homework Lib.
For this problem, we have sodium, which has a Fermi energy of 3.23 eV. Now, the question wants us to find a few things. First, it wants us to find the average energy, EAV, of the electrons at absolute zero. So, for part A here, we want to find EAV, which from the text, it's simply a fraction of the Fermi energy, which when you plug in, you get 1.94 eV. So simple plug and chug. For part B, we are trying to find the velocity or the speed of an electron that has an energy of eAV. In this one, we can just go back to the standard kinetic energy equation, 1 half mv squared, and set that equal to eAV. And if you take this over here, we see that V is just going to be the square root of 2 eAV all over the mass of the electron in this case. And that's just a constant, and you can plug all of this into your calculator or Wolfram Alpha, and you get something that's quite fast. In meters per second, we get 8.25 times 10 to the 5 meters per second. And then finally, for part C, we want to find at what temperature T we get the energy that's equal to the Fermi energy. So that's also referred to as the Fermi temperature, which is where you get a velocity that is equal to the velocity at the Fermi energy. But we want to find T. So one relation that we have is that the energy of an ideal gas, which we can write as ideal, is 3 half Boltzmann's constant times the temperature T. And by rearranging this, we can get that our T is then equal to 2 E ideal over 3 Boltzmann's constant. But in this case, the energy that we want to set equal to is our Fermi energy, which is given to us up here. So we plug in, which is the same as setting this equal to EF, put in our Fermi energy, and if you turn the crank, you get 2.50 times 10 to the 4 Kelvin. Now, I've taken this to 3 significant figures. It's actually 2,400 and, or sorry, 24,400.9999. But we'll just round it up here and use significant figures. But that completes the problem. And we can see that it was mostly just finding the correct equations and equivalencies. Easy as pie.